Hello and welcome! In this series of tutorials, I'm going to show you how to use a new optical flow wrapping node in Wrap3. So here's a common use case. Imagine we want to create a digital double of a real actor. In order to do that, we scan the actor with a variety of facial expressions using photogrammetry. Depending on a project, you may end up having dozens of such expressions. Each scan is an independent mesh. It has its own topology, number of vertices, and UV layout. To use scans in production, we need to convert them into a common blendable topology. One way to do that is to take a generic base mesh and fit it to each and every scan. First, we need to fit the base mesh to the neutral expression. In this tutorial, I'm going to show you how to do that using a standard wrapping node. The second step is to fit the neutral mesh to the other expressions. This step is much harder because for each vertex, we need to find its corresponding position on a target expression. In other words, if a vertex on the neutral mesh corresponds to some specific skin pore, to fit it correctly we need to find exactly the same skin pore on a target scan. To do that, we should not only rely on geometry, but also on texture information. I'm going to show you how to do all that using the new optical flow wrapping node on the second and third part of the tutorial. At the end, we'll have a nice set of blendable meshes. Since the correspondences between the meshes are found with almost pixel level accuracy, we'll be able to blend not only between the meshes, but also between the textures. Let's start with step 1, wrapping a generic base mesh to the neutral expression. If we go to the Gallery tab and scroll all the way down, we will see a set of 3D scans of facial expressions. The guy's name is Alex, and we're going to use his scans during the course of this tutorial. First, we need to load a neutral scan. Let's rename this node to Scan. Now we need to choose a base mesh. In general, you can take any custom mesh, but I'm going to use the one that comes with the Wraps Gallery. Let's rename this node to Base Mesh. I click Tab and create a wrapping node. If I hold a mouse over an input, you can see what each input means. The floating geometry is the one that is going to be deformed. In this case, it's our base mesh. The second input is a scan. It's important that the base mesh is pre-aligned with the scan before wrapping, so I'm going to adjust its position and slightly increase scale. You can see that our base mesh contains a mouth socket and there's nothing on the scan that we can fit it to. So we need to exclude the mouth socket from wrapping process. To do that, I need to create our Select Polygons node. I use E to switch to the Editor tab. To select the mouth socket, I click on two neighbor polygons with the Shift key and press the Loop button. Then I click Grow multiple times until the entire piece is selected. Or, if your base mesh has polygroups, like in this case, you can go to Add Polygroup and select one from a drop-down list. With this done, we can go to the wrapping node and click Compute. Here and later, I'll speed up the video so that we don't have to wait until the computing is finished. Here we go. The result is nice, but this particular area was fitted incorrectly. We can fix that by adding a few control points to help the algorithm. I click Tab and then create a Select Points node. Please make sure to plug inputs into the Select Points node in the same order you plug them into the wrapping node, otherwise the points will be applied to the wrong models. I'm going to add several control points for the left and right eye. My preferred way to do that is to set 2 points on eye corners and then add another 2 points halfway between them on the eyelids. I'll also add a couple of control points for the lips. To increase robustness, I can go to Advanced Parameters of the wrapping node and increase Smoothness final parameter to 0.08. Let's click Compute again. This time it's much better. We can go with this mesh, but for the purpose of this tutorial, I think it's better to increase the density of the mesh by using mesh subdivision. I click Tab and create a subdivide geom node. I think that the first subdivision should work okay. Now we can create another wrapping node and fit the subdivided mesh again. We no longer need point selection because now the base mesh and the scan have very similar shapes, but we still need to create new polygon selection because the topology has changed. I'm going to select the mouth socket again using polygroups. This time we can use lower smoothness final value to better fit subtle details on the scan. Let's click Compute again. Here we go. Note that I could have subdivided my base mesh from the beginning and wrapped it with a single pass. The reason why I prefer this two-steps approach is because it turns out to be more robust and faster. Okay, now I'm going to save the result to an OBJ file. To do that, I create Save Geom node. I call the file wrapped.obj. Don't forget to click Compute Current Frame to save the file. Let me leave it out of the scope of this tutorial, but I'd highly suggest spending some time to fix and clean up small wrapping artifacts, because the quality of the neutral base mesh is going to be vital for further processing steps. Okay, now we need to transfer the texture from Alex's scan to the neutral mesh. To do that, I create Transfer Texture node. I set the resolution to 4096 by 4096, but you can also use higher values for better quality. I plug the scan as the first input and the neutral mesh to the second input. You can see that the inner part of the lips have some artifacts. The mouth socket texture also looks messy. Since the neutral texture is very important for further steps, I'm going to fix it quickly in Photoshop. Before that, let's create a Save Image node and save the image file to PNG. I'm going to call it wrapped.png. I click Compute Current Frame to save the image. Let's load the texture in Photoshop. I pick a color sample from the inner part of the lips. Then I select two regions where the mouth socket is located. I create a solid color layer to fill those regions with a selected color. Use Alt-click between the layers to apply the effect to the background layer. I'm also going to remove the artifacts inside the lips. We can use Eraser tool to clean up errors of projection. With this done, we can save the texture back to File. Let's go back to Wrap and load the resulting texture. I use Extrapolate node to fill all the empty areas on the texture. After that, we can save the image again. Let's apply the projected texture to a wrapped model using a Set Texture node. Alright, our neutral mesh is ready and we can move on to the second step. Thank you, and I'll see you in the next tutorial.